This video is meant for people who are taking standardized tests, whether it's the SAT, the ACT, the GRE for graduate programs, the GMAT for business school, or other standardized tests in other countries. And what I'd like to do here, you see these areas of math that I'm going to talk about, and all of these areas are also listed. If you want to look at the timestamps in the description box, if you want to jump around, you can easily do that. But I just want to refresh your memory, standardized tests, of course, your time is limited. And sometimes, solving the problem is tough, but even just figuring out how to solve it in a few seconds is really tough. Trying to remember some little tips and tricks to save you time. So I'd like to go over those. And let's jump real quick into divisibility rules. Remember this one? How about if you want to figure out if a number is divisible by 3 or not, and you want to find a quick way to do it. So I'm just making up a number here. I don't know. How about 246? How about that one? The rule is if you add up the digits, and 2 is what? The hundreds digit, and 4 is the tens digit, and 6 here is the units digit. You could also call it the ones digit. If you add up the digits, so 2 plus 4 plus 6, so that's what? 12. If the sum of the digits is divisible by 3, then the whole number is divisible by 3. How about divisibility by 4? What's the rule there? Well, let's take a number, I don't know, how about 512? How about that one? If the last 2 digits are divisible by 4, so here in this case 12, if the last 2 digits are divisible by 4, that means the whole number is divisible by 4. So 512, I already know it's divisible by 4. If I had, 632, 8 times 4 is 32. So 632 is divisible by 4. So that's the rule on divisibility by 4. How about divisibility by 5? Here I lined up some numbers here. If a number ends in a 5 or a 0, a 5 or a 0, then it's divisible by 5. Now if it doesn't, so 7 not divisible by 5, 12 not divisible by 5. So if it ends in a 5 or a 0, divisible by 5. How about 6? Divisibility by 6. The rule is that if a number is divisible by both 2 and 3, then it's divisible by 6. So 5, of course, not divisible by 2 or 3. 6, yeah, it's divisible by 2. It's also divisible by 3. It's 2 times 3. 7, not divisible by either one. 8, it's divisible by 2, but 2 and 4. So that's not divisible by 6, nor is 9. But 12. 12, it's 2 times 6. 6 is 2 times 3. I'm writing a dot for times. 12, it is divisible by 2, it is divisible by 3, therefore it is divisible by 6. All right, how about other ones? 7, that's kind of a complicated rule. It's actually not really worth learning, to be honest with you. And then finally, how about the divisibility rule by 9? So suppose I had, 819. How about that? 819. It's similar to the divisibility rule by 3. If you add the digits, so in this case 8 plus 1 plus 9, that adds up to 18. If the sum is divisible by 9, then the whole number is divisible by 9. So some quick divisibility rules can save you a little bit of time. Now let's talk about prime numbers. In a little review, what is a prime number? So if I wrote, let's see, I'm going to write the first few, 2, 3, 5, 7. Those are the ones that are less than 10. And then the ones that are greater than 10, you definitely want to memorize these, 11, 13. They're an infinite number of prime numbers, but these are the ones you definitely want to memorize. If you know more, that's even better. What's a prime number? It's a number that's only divisible by 2 different numbers, 1 and the number itself. So 2, is 1 times 2. And here again, I'm writing a dot for times. 3, 1 times 3, 5, 1 times 5, etc., etc. 13, 1 times 13. How about 15? Well, 15, not a prime number. It's divisible by 1 and 15, yes, but it's also divisible by 3 and 5, so it's not prime. Now here's a good question. Suppose you have a number, how about 97? And you wonder, is it prime? How would I figure it out? If it's a number that's less than 100, all you have to do is ask, is it divisible by 2, 3, 5, or 7? So 97, well, of course, it's not divisible by 2. It's not an even number. Is it divisible by 3? Well, we use our divisibility rule. 9 plus 7 is 16. Nope, not divisible by 3. Is it divisible by 5? Well, no, 97, it doesn't end in a 0 and it doesn't end in a 5, so it's not. How about is it divisible by 7? Now let's see, 7 goes into 9 once. Subtract a 7, a 70, and I have 27. 7 does not go into 27. 7 times 4 is 28, but not 27. So that means that 97 is prime. So any number less than 100, if you want to know if it's prime, just see if it's divisible by 2, 3, 5, or 7. If it's not, then that means it's prime. Okay, let's talk about multiplication. How about you have, I like this one, how about you had 12 times 15? 12 times 15. Well, one thing you can do, if a number ends in a 5, sometimes it takes a while to do the multiplication. What you can do though, 12 times, if I take the 15, if I double it, 30, and cut it in half at the same time, that's the same as 15. So doubling and halving. This is a little easier. Why? Because 2 goes into 12 6 times, and 6 times 30. 6 times 30 is 180. So that can be a little time saver. Doubling and halving. When you have a number that ends in a 5, and you have an even number that you're multiplying by. Here's a little time saver. Suppose I wanted to multiply 7 by, I don't know, let's say 24. Well, of course, we could do 24 times 7. It doesn't take all that long. But one thing you can do, 7 times, well, 24, it's the same as 20 plus 4. I can distribute, remember that word, distribute the 7 to the 20. 7 times 20 is what? 14 followed by a 0, 140. Plus, I distribute the 7 to the 4, 28. Yeah, it's 168. It's 168. So distributing can be really helpful. It's especially helpful to memorize some perfect squares. Or maybe I should say refresh your memory on some perfect squares. So suppose you're asked, what's 11 squared? Well, let's see, that's 11 times 11. That is, well, 11 times 11, that's the same as 11 times 10 plus 1. So if I distribute the 11, 11 times 10 is 110, plus 11 times 1 is 11. So 121. 11 squared is 121. Let's do some more. How about 12 squared? So 12 squared, it's the same as 12 times the quantity 10 plus 2. If you have numbers inside parentheses, you call it the quantity, 10 plus 2. So let's see, 12 times 10, 120, plus 12 times 2 is what, 24? Those add up to 144. So yeah, 144. 12 squared is 144. How about 13 squared? So we have what, 13 times the quantity 10 plus 3. 13 times 10 is 130, plus 13 times 3 is what, 39. So you have 169. 13 squared, 169, really good to memorize. Let's see, 14 squared, 14 squared. So 14 times the quantity 10 plus 4, okay, 14 times 10, 140, plus 14 times 4. Well, 14 times 2 is 28, times 2 again, 56. So 140 plus 56, 196. 14 squared is 196. And then how about 15 squared? 15 squared, so we got 15 times, 15 is the same as 10 plus 5, so the quantity 10 plus 5. 15 times 10, 150, plus 15 times 5 is 75, so 225. 225, 15 squared is 225. Really good perfect squares to memorize. Here's a good one to remember. How about, let's see, how about multiplying by 9? How about 17 times 9? Well, 9 is the same as 10 minus 1. So I could say, well, that's the same as 17 times 10 minus 1. Here I'm not adding, I'm subtracting. Well, let's see, 17 times 10 is 170, minus 17 times 1, of course, is 17. So 170 minus 17. Well, 170 minus 10 is 160, minus 7 is what? 153. So multiplying by 9, sometimes it's a little quicker to multiply by the quantity 10 minus 1. A little more on multiplication. Suppose you wanted to double a number. I don't know, how about 147? Well, you know, if you multiply by 2, we know what to do, right? 7 times 2 is 14, carry the 1. 2 times 4 is 8, plus 1 is 9. 2 times 1 is 2, it's 294. All right. A little time saver, and I'll erase this. A little time saver, I'll write 147 again. Why don't I multiply by the hundreds digit first, and then the tens digit, and then the units digit? So what do I mean? 100 times 2 is 200, plus, well, 4 times 2, 40 times 2 is 80, plus, and then 7 times 2, of course, is 14. So this is easy. 492, 294. So those are some little time savers on multiplication. Let's talk about division. Suppose I wanted to divide 180 by 5. I mean, I could write it this way, right? 180 divided by 5. Or if I wrote it this way, 180 over 5. Suppose I multiply this by 2 over 2. 2 over 2 is 1. You can multiply anything by 1 without changing its value. What's the advantage of this? Well, 5 times 2 in the denominator, 5 times 2 is 10. In the numerator, 180 times 2, 360. Hey, I just cancel a 0. It's 36. So not that it takes all that long to divide 180 by 5, but a little time saver. Here's a little division tip that some people might find a time saver. Maybe not most people, but some people, and it depends on really what region you're from. In some countries they teach this, in some they don't. In my state they taught it, but in most states I'm not sure if they do or not. But suppose you had, let's say, 534 divided by 3. One way to do this, which some people would find it a little bit of a time saver, if I took the 534 and I spaced it out, 5, 3, 4, and I divide by 3. Let's see, 3 goes into 5 once. What you would normally do is what? Subtract the 3, so you get 234, blah, blah, blah. But another thing you can do, that takes up a lot of space, right? That's the thing, it takes up a lot of space. What I could do is 3 goes into 5 once with a remainder of 2. All right, so I put the 2 here next to the 3, so I have 23. 3 goes into 23, well, let's see, 7 times 3 is 21, 7. 23 minus 21, another remainder of 2, so I put the 2 here. 3 goes into 24, how many times? 8 times. So you see, I did the same division, but I really limited the amount of space. So maybe it was a time saver, but even more so, it restricted your space, which of course on a standardized test, you don't necessarily have a lot of room. Here's another example. How about 812 divided by 7? Well, if I spaced out the 812, if I wrote 812 divide by 7, all right, 7 goes into 8 once. With a remainder of 1, so I put the 1 here. 7 goes into 11 once. All right, 11 minus 7, that's a remainder of 4. 7 goes into 42. 7 times 6 is 42. So the answer would be 116. Helpful for some, not for others, but worth pointing out. Here's another little time saver. Generally speaking, dividing by a 2-digit integer or an integer that has even more digits. So suppose I wanted to divide, I don't know, how about 99,000 by 55? Well, I don't really want to do that. It'd be great to turn this digit, this 2-digit integer, into 1 digit. So if I had 99,000 divided by 55, well, hey, 55 is divisible by 11, and so is 99. So I would have what? This is the same as 9,000 divided by 5. I'll write it in a different way. If I look at the 55, I divide that by 11. I look at the 99,000, I divide that by 11. Well, now, hey, 5 goes into 9,000. That's a little quicker. And by the way, going back to something we said before, 9,000 divided by 5, what's a quick way to do that? Here again, multiply by 2 over 2. So the denominator, 5 times 2 is 10. The numerator, 18,000. And so I cancel a 0, and that's what? 1,800. So those are a few tips on division. Let's talk just a little bit about subtraction. Suppose I wanted to, let's say, 1,000 minus 564. One thing you could do to save a little bit of time, and I'll rewrite this as 1,000 minus 564. If I subtract 1 from both of these, so if I turn the 1,000 into 999, and I subtract a 1 from the 564, I turn that into 563, well, that math is a little easier, and it's going to get you the same result. 9 minus 3, 6. 9 minus 6, 3. 9 minus 5, 4. 436. A little quicker to do that than to, for example, write 1,000 minus 564. And what do you have to do? You have to keep borrowing a 1. So I'd have to borrow a 1 and put it here, and then borrow another 1 and put it here. That's really time consuming. Here's another thing that's really good to remember about subtraction. Suppose I wanted to know, let's see, what's 3/4 minus 2/3? Well, the sort of formal way to do it is to find common denominators. So what I'd have to take the 3/4 and multiply that by, we have 2/3 over here, by 3 over 3. And I'd subtract 2/3 multiplied by, I have a 4 over here, 4 over 4. So that's what? That's 9/12 minus 8/12. I mean, that took a little bit of time, right? But let's get rid of this. A quicker way to do it, called the butterfly method, I'm going to write this. 4 times 3, so you multiply them, 12. That's your common denominator. And then let's see, 3 times 3, 3 times, I'll put the 9 up here, minus 4 times 2, I'll put the 8 up here. So 9 minus 8, 1/12. The butterfly method, a little bit of a time saver. And by the way, on a similar subject, suppose you wanted to know which fraction is bigger. I'll make up two fractions. Actually, I'll stick with the same two fractions for a second. 3/4, 2/3. If you wondered which one is bigger, well, similar idea. I multiply 3 by 3, I have 9 over here. I multiply 4 by 2, I have 8 over here. So hey, I know that 3/4 is the bigger fraction. You know, let's take, I don't know, how about 2/5 versus 1/3? Which one is bigger? Well, let's see, 2 times 3 is 6, or is 1 times 3, nope, 1 times 5, that's what I meant to say, is 5. Yeah, so 2/5 is bigger. So those are a few tips on subtraction. Let's talk about adding numbers. And this is something you might see on the GMAT or the GRE. Suppose I wanted to add the numbers 1 through 10. A quick way to do it, let's split the numbers down the middle. So we have the first 5 numbers, and then 6 through 10, the last 5 numbers. Let's see, 1 plus 10 is 11. 2 plus 9, 11. 3 plus 8, 11, etc., etc. 5 plus 6, 11. So I have some pairs of numbers here. I have 1, 2, 3, 4. I have 5 pairs of numbers, 5 pairs of numbers, and each pair has a sum of 11. So the answer is 5 times 11, 55. The numbers 1 through 10 add up to 55. Let's look at another example. Suppose I wanted to add the numbers 1 through 100. Let's split this down the middle. So we have 1 through 50, that's the first half. We have 51 through 100, that's the second half. So 1 plus 100, 101. 2 plus 99, 101, etc., etc., etc. 50 plus 51, 101. So how many pairs do I have? 1, 2, 3, 4. I have 50. I have 50 pairs, and each pair has a sum of 101. So the sum of all the numbers from 1 to 100 is what? 5,050. And you do see things like that on the GMAT and the GRE where this can be very helpful. And there's a formula here. Let's say the number of numbers is n. So here there are 100 numbers. Let's say the number of numbers is n. 50 is n divided by 2. So n divided by 2 times, well, the 101 is what? The 101 is, well, n plus 1. N over 2 times n plus 1, that gives you the sum of all these consecutive numbers. Here's something else to know. Let's talk about medians, trying to fit those in. So those are 11 numbers, and I'll number them. So 2 is the first number. I'll keep going. If you can't read my handwriting, this is first, second, third, fourth, fifth, all the way to 11th. And you wonder, the median, that's the middle number, right? You wonder, the median, well, which one is that? Is it the 5th? Is it the 6th? Is it the 7th? The way to do it, take the number of numbers, that's 11, so I'm going to write 11, add 1, and then divide that by 2. So 11 plus 1 is what? 12. 12 divided by 2 is 6. So the median is the 6th number. You take the number of numbers, in this case 11, add 1, divide by 2. The median would be the 6th number. And as you may know, if they're an even number of numbers, suppose there were, let's see, I'm kind of running out of room, so maybe I'll just erase 52. Maybe I'll erase 52. If there were 10 numbers, the median is defined as the average of the 2 in the middle. So the median would be here, the average of the 5th number and the 6th number. It would be the average of 9 and 13. And what's that? 9 plus 13 over 2 is 22 over 2 is 11. So 11, even though 11 is not a number on the list, a number in the set, it is nonetheless the median. Suppose I had the numbers, I'm going to write 10 through 15. How many numbers are there from 10 to 15 inclusive? That's the key word, inclusive. That means include all of them. Well, it's not 15 minus 10. It's not 5. It's 6 numbers, 10, 11, 12, 13, 14, 15, 6 numbers. How would you figure that out? So suppose you wondered, how many numbers are there from, I don't know, 746 to 858. How many numbers are there? Well, the thing to do is you take the last number, you add 1 to it, so 859, and then you subtract the number you started with. So it would be 859 minus 746. So that's what? 311. That's 113. So from 746 to 858, how many numbers are there inclusive? There are 113 numbers. And we can apply that to what we just did with 10 through 15. How many numbers are there from 10 to 15 inclusive? Well, if I took 15, if I added 1, so that's 16. If I took 16 and subtracted the first number, 16 minus 10, 6. There are 6 numbers from 10 to 15 inclusive. Here's another little thing on adding numbers. Suppose I wanted to add about 634 plus 228. One thing you can do is take the 634, round it up to something that's a little easier. So how about 640? And then the 228, how about I round that up to 230? Well, 640 plus 230, that's not too hard. 640 plus 230 is what, 870? That's 870. Now, but in order to get there, what did I do? The 634, I added 6. So 640 is a little too big. 228, I added 2, so that's a little too big. What do I have to do? I have to just take the 870 and subtract the 6 and the 2. I have to subtract 6 plus 2. I have to subtract 8. So it would be what? 862 is the sum of 634 and 228. Let's talk a little bit about percents. And I'm going to start by talking about tips. Suppose you want to leave a tip. And I don't know, let's say the bill was $85. If you wanted to leave 10%, well, we know what that is, right? You just move the decimal over 1, so it'd be 8.5. It would be 850. Suppose you wanted to leave 20%. Well, a couple ways to figure that out. For one thing, 20%, which is what? 20 over 100, which is 2 over 10, which is 1 over 5. 20% is 1/5. So what I could do, I'll erase this and rewrite it. If the bill was $85 and I wanted to leave a 20% tip, I could just divide that by 5. And dividing by 5, I mean, we talked about this. You could do this, 85 divided by 5, but what's even better, multiply by 2 over 2. So 5 times 2 in the denominator is 10. 85 times 2. Well, 80 times 2 is 160. 5 times 2 is 10. So 170, you would have what? A $17 tip. Suppose you wanted to tip 15%. Well, that's what? 10% plus 5%. That's 10% plus half of 10%. If the bill were $85, I wanted to leave a 15% tip. Well, I'd start with 10%. We said 10% would be what? 8.5 or 850. And then I would add half of that, which is what? 425. So I would leave a tip of 850 plus 425, which is what? 1275. Let's see, what's next? Counting numbers. Oh, I already talked about that. How about ratios and proportions? Let's see, what's a ratio? Suppose you're told the ratio of boys to girls in a classroom is 2 to 3. So for every 2 boys, there are 3 girls. You also want to think about the total quite often. So for every 2 boys, there are 3 girls and 5 kids. Now that's just the ratio. That doesn't mean there are actually 5 kids in the class and 2 boys and 3 girls. The numbers could be a multiple of that. Suppose you want to write ratios also as a fraction. So B over G equals 2 over 3. That's a part-to-part ratio. Boys to total is 2 to 5, 2 over 5. That's a part-to-whole ratio. Well, suppose you were told that there were, I don't know, 45 kids in the class. So I'm going to write this, 45. And you want to know how many boys were there. This equation, 2/5 equals x over 45, that's called a proportion. Proportion is an equation that sets 2 ratios equal to each other. Well, your instinct would probably be to cross multiply, and you can certainly do that. X times 5, 2 times 45. You actually don't even have to do that. What you could do is just multiply both sides by 45. So here, let me write this again. 2/5 equals x over 45. You would just multiply both sides by 45 and simplify. But that's taking a while, right? Here's a much quicker way to do it. To get from 5 to 45, what did I do? I multiplied by 9. So to get from 2 to x, I multiply by 9. So x is 9 times 2. X is 18. Or if I wanted to write it this way, 2/5 equals x over 45. Well, what did I do? I multiplied 2/5 by 9 over 9. Multiplying by 1, I put 1 in quotes. 9 over 9 is the same as 1. You can multiply anything by 1 without changing its value. So that's what you do. You just ask, to get from 5 to 45, what would I multiply by? I would multiply by 9. So to get to x, 2 times 9, 18. And if I wanted to write it over here, so the total, suppose the total were 45. To get from 5 to 45, I multiplied by 9. So how many boys would there be? 2 times 9, 2 times 9, 18. So a little bit on ratios and proportions. Last but not least, let's talk about rates. And what's a rate? A rate is, well, it's a type of a ratio. It's a comparison of one unit to another unit. Now, there are some, of course, we're really familiar with, rate, speed. Speed is a rate we see all the time. That's a measurement of distance to time. So one measurement, distance, over another measurement, time. You see speed. You might see pay, a pay rate. Pay would be what? It might be dollars, for example, or euros over, again, time. So maybe you're paid, I don't know, $18 per hour. I forgot to mention speed. Maybe you're going 60 MI for miles per HR for hour. You might get work. Now work, if you get a work problem, and this would be more common on the GMAT or the GRE, work is a measure of jobs over time, where quite often the numerator is 1 and the denominator is not. So just be on the lookout for that. When you talked about speed, the denominator was 1 hour. But oftentimes with, quote, work problems, it's often one job over a certain amount of time. So it might say that a certain machine can do one job in 2 hours. Or it might say it can do X units in 2 hours. So you just want to be aware of that. But other rates that come up, exchange rate. I'll write this, exchange rate. It would be a ratio of one currency to another currency. So there again, you're comparing different types of units. So maybe it's dollars to euros, for example. And another one, I'm going to do some erasing here. How about interest rate? We don't really think of an interest rate as a rate, but it really is. And it's a rate of what? A measure of interest to the investment or the principal. I'm just going to write investment. So if an investment pays an interest rate, how about 8%? That is let's say in dollars, $8 for every $100 invested. It's a rate of interest to investment. Okay, now one final thought. I was talking about speed, rate, distance over time. I like to think about it as, so if I draw a line here, I like to imagine the distance on the top of the line and the time on the bottom of the line. That's just me. And that's maybe a good way to picture it. But if you ever get a speed problem, rate is distance over time. Hey, if I multiply both sides by t, rate times time equals distance. It's a really good idea. This is a really good way to organize your information, right? Rate times time equals distance. And then suppose there were two people going at different speeds, different rates. Maybe there's person A going at a certain rate and there's person B going at a different rate. And you can fill in all the boxes, or at least some of the boxes. And perhaps the total distance is, I'm writing as if this were a counting class, a double underline. Maybe the total distance is this. So it's just, I don't want to get into it too much, but that can be a really good way to organize your information. Rate times time equals distance, and write a little chart underneath. All right, if you have any math tips and tricks that you'd like to share, by all means, leave them in the comment section. I'd love to create another video. Hope this was helpful. If it was, please click the like button, share it with your friends. I wish you the best of luck on your next standardized test.